Yeah, hello guys, welcome to my channel. So in this video, I am starting a new playlist on the multi-threading concepts. So yeah, I'll start with the basics of multi-threading. That is, what is a process and what is a thread. So basically, if you see the definition of what is a process, so I can say a process is simply a Java program that is currently running. Okay, that means if you are, I can show you the examples. Like if you are opening a Chrome browser, so it will create one process. Okay, that is Chrome process. And if you are opening like Visual Studio Code, that also create a process. So if you go to the task manager, you can see all the processes that are running in your application. So and every process that you create, so it has its own memory, the resources and the execution environment. So and these processes are isolated to each other. So that means, what do you mean by isolated from each other? Means this for example, if your Chrome application or the Chrome processes crashes, okay, then this VS Code processes will keep on running. That means the processes are independent of each other, and one process will not affect the other process. So that is what I have mentioned here. Like if Chrome crashes, then the VS Code keeps running because they're separate processes. So now coming to thread. So let's see what is the thread. A thread is the smallest unit of execution inside a process. And the process can contain many threads. So yeah, so thread is nothing but it's the smallest execution inside a process, and a process can have multiple threads. So this Chrome process can have multiple threads. So I'll give you a real-time example of a thread. So imagine you are running your Spring Boot application. So whenever you are running your Spring Boot application, so I will call it as a process. That is a Java process that has been running. Okay. So after that, inside the process, you have a main thread, and there is a thread which is related to the database, and there is a thread which is related to the request, logging, and the scheduler. So these threads, all these threads will work together inside the same process. So what is the process here? It's a Spring Boot application. The Spring Boot application is the process, and all these threads work together in order to make this process run successfully. So and I'll give you one real-time example of how the process and the threads work. Okay, so imagine you are building a house. That building, when you are building a house, that complete house, we call it as a process. And in order to build a house, you need so many things, like you need the carpenter, you need the plumber, the electrician, interior designer. So all these are called as threads. So that house is called as a process, and all these people who are working in order to build that house, those are called as threads. So each worker, like the painter, electrician, plumber, carpenter, we used to call them as threads, and they work all together for the same purpose, that is building of the house. And you can see all threads work on the same process. Now we will understand what is the process memory. So process memory is something that is related to the memory with respect to process. Imagine you are storing a string, like string company is equal to Google. So this variable will be stored in the process memory. And imagine you have 10 threads, and all these 10 threads will share the same process memory. So since they are sharing the same process memory, so there are some advantages and also there are some disadvantages. Okay. So but the point you need to remember here is, all the threads share the same process memory. And coming to the next part, why do threads share the same memory? So that is obviously the question. Why do threads can't have the different memory? So I'll give you the answer for this. So what happens is, imagine I have written some piece of code over here. So employee service dot get employees. So this employee service dot get employees will return you the list of employees. So imagine you have 100 threads running in your application, and this employee service dot get employees will return the 1,000 employees. And if you want to, if you want to have a separate copy for each thread, then if every thread has its own copy, then definitely the memory will get exhausted. So instead of all these threads will share the same memory, so that the communication can be made faster and efficient. So that is why, like, in order to reduce the memory usage, all the threads will share the same memory. So after learning all these concepts, like what is process, what is the thread, so now we will come to understand why we need multi-threading in our applications. So why multi-threading? So I have given you a small example to make you understand better. So imagine you are working on a bank application, and imagine whenever you want to send like money to someone, what you will do is you will just click on the transfer money button. So whenever you click on the transfer money button, like the following sequence of operations will take place. So like it will save the transactions, it will send an email that so and so amount has been debited from your account, and also you will get an SMS. And like for example, if you are sending 500 rupees, that 500 rupees has to be deducted from your balance, and the logs has to be written and notify the Kafka for like event driven architecture, and update the analytics. So imagine if everything happens on a single thread. If everything happens on a single thread, then the user has to wait until all these operations needs to be completed. Okay. So with multi-threading, what happens is the main thread is the one which is responsible to like the application starts with the main thread, and all the other threads, this save transactions, send an email, send an SMS, all these operations, all these functions will be taken care by other threads. So since many threads are working in order to complete this, so the task can occur concurrently. Concurrently means in parallel, and which will improve the performance. So I think you understood the examples. So like for example, if you want to do some job, if one people do this job, it will take 10 days. Imagine if one people do this job, it will take 10 days. Imagine if 10 people do the same job, then it will take only one day. So that's what the concept of multi-threading. Like with the help of multiple threads, you can finish the work quickly, so which improves the performance of the system. So now we will try to understand why not create unlimited thread. So now you understood that with the help of threads, we can complete the work faster. So as a beginner, you will get some question like why not we create unlimited threads, so that our application, our task can be completed very quickly. So that is one of the beginner question. So like imagine if you are asking if threads are good, why don't we create 10,000 threads? Because whatever the threads you are creating, that is not free. Every thread that you are creating has been associated with the CPU, memory, and the operating system resources. So if you are creating too many threads, it can make your application slower and even crash it, because it is associated with the CPU, memory, and also the operating system resources. So that's why you cannot create unlimited threads. And in order to support this multi-threading concepts, Java has given something known as thread pool. So thread pools where we can use the threads through the executor framework. So I will explain you the executor framework in the upcoming videos. For now, you just remember there is a concept of thread pool, and using the executor framework, we can access those thread pools. So next, after understanding all these things about what is a process, what is a thread, now let's try to differentiate between the processes and the threads. So you can see it here in the example. So process, what is the process? It's a running application. And what is the thread? And it's the smallest unit of execution inside a process. And the second thing is every process has its own memory, what we call it as process memory, and the thread will share this process memory. And process is a heavyweight because it has multiple functions, multiple tasks to do, so it is a heavyweight. And threads is a lightweight because every thread is it's a part of a process, and it's the smallest unit of execution inside a process, so it's lightweight. And process, it will take some time to create, so that's why we can say it is slower. And threads, it's faster to create. And process is isolated. What do you mean by isolated? Means So every process is independent of each other. If you are running a Chrome application, and if you are running a VS Code application, and if you are playing a game, if Chrome application crashes, it won't affect your VS Code or the MySQL or the gaming thing what you are doing. Okay, so all the processes are isolated and are independent of each other. But when it comes to thread, so they are not isolated, so they communicate with each other through the shared memory, that is process memory. So, and one process can have multiple threads. As I said earlier, a process can contain multiple threads. And other thing is a thread is nothing but it's a part of process only, it belongs to one process. So now we understood what is the difference between process and thread, why we need multi-threading, and what is the advantage and disadvantages of multi-threading. Everything like you understood. So now we will take up one small program. So I'll explain. So like what happens in this. So this is a program where I will be verifying which is the current thread that is running. Okay. So as soon as I run this application, so the JVM will start, and once the JVM starts, it will create a main thread. Okay, as you all know that it will create a main thread, and that main thread is responsible for the execution of this main method. So how can I show that the main thread is the one which is responsible for the execution of this main method? So I have written a simple code snippet. So you can see here, like I have used a method called as thread.currentThread.getName. So when I run this application or a small program, so you can see it is displaying main. So that means the main thread is the one which is responsible to create this main method. Sorry, which is responsible to run this main method. Okay, so I think you understood the main method, and I am going to discuss some of the interview questions that are mainly asked in the interviews. So I am showing you the questions as well as the answers. So so why are threads faster than processes? So this is one of the important question. So as you all know that the threads share the same memory and resources, and because of which creating and switching between the threads is very much easier when compared to creating and switching between the processes. And the reason for the threads and the reason for the threads are faster than processes is because of the same shared memory. So you remember this. So we'll be going to the next question. So what is the biggest advantage of threads? So as I explained you earlier, the biggest advantage of threads is so concurrent execution. That means the multiple threads can execute simultaneously, and it will complete the task within the short duration of time. And also, since all these threads sharing the same process memory, so the application responsiveness will be very fast, and also that program execution will complete as quick. Okay. So and also this is one of the disadvantages I am going to share. So this is the next question. So here we have the next question. So what is the biggest challenge with the threads? Okay, so since as we all know that all the threads will share the same memory, so improper access to the shared data. Okay, so improper access to the shared data can create something some conditions known as the race conditions, a data inconsistency, and also deadlocks. Okay, so this is one of the biggest challenges in threads. Also we can say it's a disadvantage of threads. So Java provides some concept called a synchronization, and the synchronization mechanisms we have in order to solve this problem. I think we have covered most of it. Like we have covered what is the process, what is the thread, and what is multi-threading, or like what happens, how the program runs without multi-threading and with the help of multi-threading. And I have shown you the program which is a thread that is currently running when you start your application, and some of the interview questions that I have discussed so far. So if you have any questions or any comments, you just drop it in the comment section, and thank you so much for watching.